Okay, welcome back to part 2 of the exam. I did mention I will make a further video covering question 4. As of now, we'll continue on with the rest of the exam. So now we are on to probability. And here is our context. There are 3 team members to be selected from a group of 3 girls and 4 boys. So basically there's 7 people, we need to choose 3 of them, and 3 of them happen to be girls, 4 boys. How many different committees can be selected with no restriction? That means it could be all girls, all boys, a mix of both, and this one should be, so from 7, we're choosing 3. And this is how many, rather than a probability. So our formula otherwise known as 4, 3. A good way to check is if these two add up to the number on top, you've done something correct. This is also known as this. Which is equal to 7 times 6 times 5 over 3 times 2 times 1. Why not? And this is 6, so there's a total of 35 committees. How many different committees can be selected if a particular girl must be on the committee? Now, that means out of the girls, so let's say there's, we'll call these 3 girls and then the rest are guys, whatever. This guy must be on it. That means we choose 1. Since it's how many different, we're just multiplying the things together. And then the rest, 1, 2, 3, 4, 5, 6 times 6, choose 2. Is equal to 1 over 1 choose 1 is just 1. So we end up with this. And the way I got to here is this is equal to 6 minus 2, which is equal to 4 factorial. Right? Then this is 6 factorial over 4 factorial. 2 factorial equals 6 times 5 times 4 factorial over 4 factorial. 2 factorial equals 6 times 5 over 2 factorial, which is 2 times 1, which is 30 over 2, which is 15 committees. Mind my spelling. I don't know. We'll do both. Now, find the probability. This is where we have to find the percentage or decimal. It's different to these because these are how many, what is the probability? Anyways, find the probability that the committee contains at least 2 girls. So basically that would be 2 girls, 1 guy, or 1 boy, and 3 girls, 0 boys. So what is the probability that this is the outcome? We could either do okay, so we need 2 girls, 1 boy, or 3 girls, 0 boys. So let's find how many times we can do that. So let's choose one with 2 girls. So it'd be, we have 3 girls total, choosing 2 of them. So this is 4 girls. Multiplied by, we have 4 boys and we're choosing 1. So this would be, this is figuring out 2 girls, 1 boy. The answer would become 3 choose 1 over 2 choose 1. Oh, sorry, 3 factorial over this. Good. And clearly these cancel out. So then this would become 4 times 3 2 factorial on 2 factorial equals 12. So this is the combination of 2 girls, 1 boy. Next, we'll do 3 girls. So it'd be 3 choose 3 times 4 choose 0, because we're choosing 0 boys and we're choosing 3 girls out of 3 girls out of 4 boys. This would become over then 4 choose 0 would be, there's only one possible outcome for this. So that means the total outcomes would be 12 plus 1 equals 13. Now, this is because anything choose anything equals 1, and anything choose 0 is also 1. So there's 13 possible committees that contain at least 2 girls, because this will be 2 girls, 1 boy, and this is 3 girls. Meaning it'd be 13 out of 35. And where did we get 35 from? We got it from the first part of the question. Otherwise, you'd have to do 7 choose 3 again to find 35. So probability that there's at least 2 girls is 13 out of 35. Cool. Next question. In Agatha, Charlotte School, 45% of students play a musical instrument, 60% play sport, and 25% do neither. Let M be the event, another typo, my apologies. Let N be the event of playing a musical instrument, and S be the event of playing a sport. Using the above information, create a probability table below. So, those not familiar with a probability table, you may know it as, we'll do it over here, as a two-way table. And what we're going to do, so this is a play music column, and this M dash represents those who don't play music. This is sport column, sport row, sorry, across this way does not play sport. Now, we will always know this adds up to 1. So 45% of students play a musical instrument. That means we know this is this. And obviously that will be this. Now, 60% play sport. 0.6. You can do 0.60 if you wish. And 25% do neither. This would be this column here, because this means they don't play sport and they don't do a musical instrument, either basically saying they do neither. Now we do a simple math. This has to be 0.3. That means this has to be 0.3, and this has to be 0.15. Find the probability of a student playing either a musical instrument or sport. That means we want to find the probability of music and probability of this. Now, using the addition rule, this is the formula. From our table, we can read this is, let me get a highlighter, 0.45 plus PR of S minus 0.3. And this is this guy over here. So just to clarify, this is where we're getting each value from. Now, which becomes 1.05 minus 0.3 equals 0.75. Next question. Given that the student plays a musical instrument, what is the probability that he or she also plays sport? Here we go. This is this formula. We're going to have the probability of the intersection of sport and music over the probability of playing music. So this is going to be from our table 0.3 over 0.45. And to note, it'll be this one again. This is equal to, we can do it into 30 over 45, which is equal to 2/3. Cool. Question 7. Solve the equation 4 cos 2x minus 2 equals 0 for x is an element of 0 to 2 pi. Alrighty. So, before we get into anything, we want to put this into the form cos something equals something, rather than this messy situation. So let's do that. Let's rewrite this. Let's start with moving the 2 across and move this guy to the 4 equals 1/2. So we've got cos 2x equals 1/2. Alrighty. So now, what is the reference angle? Let's quickly draw up our table. And we can ignore sign because we're doing cos at the moment. 0, pi on 6, pi on 4, pi on 3, and pi on 2. 1, 0, and it's 3, 2, 1, all on 2. Square root, and square root of 1 is that. So we can see our reference angle is pi on 3. Let's write that down. What this means is cos pi on 3 is equal to 1/2. Now, using our symmetry, in the first and fourth quadrant, this is when it is positive. So cos 5 pi on 3 is equal to 1/2 as well. Now, this is a side note. We won't use these values, but just for additional context. So if you imagine the graph, this is pi on 3, this is pi on 3, 2 pi on 3, 4 pi on 3, and 5 pi on 3, and there's 1/2, just for additional context. So, next thing to look at is the period. Clearly, we can see it's from 0 to 2 pi. So, and since our domain is from 0 to 2 pi, and our period is 2 pi on n, which is in this case 2 pi on 2, which is equal to pi, meaning we've got 2 cycles in this period. So what we'll have is 2x is equal to pi on 3 and 5 pi on 3. This is our first cycle. The second cycle will be pi on 3 plus 2 pi and 5 pi on 3 plus 2 pi. And if we simplify them, this is going to become 7 pi on 3 and 11 pi on 3. Meaning x is going to be pi on 6, 5 pi on 6, 7 pi on 6, and 11 pi on 6. And here is our answer. The next part is going to be sketching it. I'm going to make our own grid below. So sketch the graph f of x equals 4 minus 2 to the negative x. Your graph must show the coordinates of the axis intercepts and labeled asymptotes and a scale on each axis. X and y here now. Or we can put f of x. Let's start with the intercepts. So let's see if there's any y-intercepts. So 0 equals 4 minus 2 minus x. We end up with 2 minus x equals 4. So we have log 2 4 equals minus x, and log 2 4 is equal to log 2 2 squared, which is equal to 2 log 2 2, a lot of 2's I know, which is equal to 2 because log 2 2 equals 1. So 2 equals minus x, meaning x is equal to negative 2. So we have a coordinate negative 2 and 0. Let's start with that. Let's look for y-intercepts now. What is f of x? What is f of 0? 4 minus 2 to the minus 0. That is equal to 4 minus, now, 2 to the minus 0 is equal to 1. Equals minus 1, which is equal to 3. So we have a coordinate at 0 and 3. Let's label that. Yeah. We're not even focusing on the shape at the moment, but let's think of a asymptote. So what is the asymptote of an exponential? They will look something like this, look something like this. But long story short, an exponential can never equal 0. So negative 2 to the negative x can never equal 0, meaning f of x can never equal 4. So here is our asymptote at f of x is equal to, we'll call f of x equals negative 4. We'll call it y. Never mind. So in terms of the shape, as x gets huge to the right-hand side, it'll always teeter off and never actually hit negative 4. And this is what it's going to look like. Okay, and our scale should be fine considering we have the coordinates, but it's always safe to go 2 1 0 and negative 1. Okay, final question. Consider the function f of x equals x plus 2 squared times x minus 1. Show that in extended form f of x equals x cubed plus 3x squared minus 4. Basically, they want us to expand. Whenever you see a show that like this, basically saying, here's some 3 marks. F of x is equal to x plus 2 squared, x minus 1. Now, I like to always do this slowly. X plus 2, x plus 2, x minus 1. Turns into x squared plus 2x plus 2x plus 4 x minus 1. Simplify this out. X minus 1. That equals x cubed plus 4x squared plus 4x minus x squared minus 4x minus 4 equals x cubed plus 3x squared plus 0 minus 4. And if you look at it, we've got the same answer. Easy way to check. Find the coordinates of the turning points of y equals f of x and state their nature. You do not have to justify it with a gradient table. Now, whenever we think of turning points, a turning point appears when turning point appears when the gradient is 0. In other words, whenever what x is when the derivative equals 0. So we have y is equal to, so let y equal f of x, as the question has already said, y equals x cubed plus 3x squared minus 4. That means dy dx is equal to 3x squared plus 6x. So we want the derivative to equal 0. And let's find what x has to be. That means x is equal to 0 or x is equal to -2. So find the coordinates of the turning points. We have to find the coordinates, we'll sub back in each individual coordinate. So we found there's a turning point here and a turning point here. In other words, turning point at x equals 0 and x equals -2. So let's sub that back into f of x. This will find the y coordinate of the turning point. -4 and f of -2 equals -8 plus 12 minus 4, which equals 0. So our coordinates are 0 and -4 and -2 and 0. Now, just from seeing this y value is negative, this y value is positive, meaning that this is going to be a local maximum and this is going to be a local minimum. Because if there's two turning points, the one that's smaller or lower down in terms of y will be the minimum, and the one that's bigger in terms of y will be the maximum. Now, there should only be a stationary point of inflection if from a cubic if there's only one turning point found. Now, if you find that you have two turning points and one of them is stationary point of inflection, it would be a quartic graph. So, for the graph of y equals f of x, find when the derivative f dash of x is less than 0. So let's see what this graph roughly looks like. So at -2 and 0, it has a local maximum, and at 0 and -4, it has a local minimum. So it's going to look roughly like this. This is a very rough sketch, but if this is a local minimum at -0 and -4, everything else has to be going upwards. And if at -2 and 0 is a local maximum, everything else is going downwards. Now, what does it mean for f dash of x to be less than 0? It means that the original graph is decreasing. So let's find when this graph is decreasing. So from left to right, clearly we see it's increasing from -infinity to -2, it is increasing, so it is not this part of the graph. From -2 to 0, we can see it is decreasing. So far from -2 to 0, it is decreasing. And from 0 to infinity, you can see it's increasing. So that would mean that the graph is decreasing when x is in between -2 and 0. Cool. Find the area of a region bounded by the x-axis and the graph of y is equal to f of x. So find the area of a region bounded by x. Cool. So if we get rid of these red arrows, we don't have to know exactly what the graph looks like, but we can roughly see just from knowing the turning point. So the area bounded by the x-axis and the graph of y is equal to f of x. It would be this part because there's nothing bounded here and nothing bounded here. Here we have an enclosed shape. So we need to find when f of x equals 0. And that's because we're finding the coordinate of when it hits the x-axis. And the x-axis is y equals 0. Now we should get an answer x equals -2 already. We are looking to find the second one. So our f of x is x cubed plus 3x squared minus 4. And we already had it in quite nice form. So clearly we can see that it equals 0 at x equals -2 or x equals 1. Now, in order to find the area, all we have to do is from -2 to 1 of f of x, which is x cubed plus 3x squared minus 4. But this area from the graph, it should give us a negative area because it is underneath the graph. If it was above the graph, for example, here, it would be positive. So we can either flip the sign afterwards or put the negative sign first. It doesn't really matter. So let's rewrite this. Cool. So we remember, keep the negatives at the front. Take the antiderivative. So 1. Now, let's do this. 1/4 plus 1 minus 4 minus 4, 8, 16, 4 minus 8 plus 8 is equal to 1/4 minus 3 minus 4, which is equal to, let's get rid of all these negatives. -1/4 plus 3 plus 4 equals 7 minus 1/4 equals 28 on 4 minus 1 on 4 equals 27 on 4. This is your answer. And obviously, units squared. That is the exam. I will go into depth on each question if needed. So just let me know, comment down below, or send me a message. Thank you for watching.